Okay, hello everyone. This is a very short lesson on identities from your textbook and मैंने इसके ऊपर थोड़े होमवर्क दिया था आपको और बोला था कि आप ज़रा आइडेंटिटीज़ देख लीजिए। सो यहाँ की जो आइडेंटिटीज़ हैं वो बहुत बेसिक हैं लेकिन बहुत इम्पॉर्टेंट हैं और आपके किताब में हर एक आइडेंटिटी के ऊपर कुछ बहुत ही अच्छे प्रॉब्लम्स हैं जो मैं यहाँ पे नहीं करूँगा क्योंकि बहुत अच्छा दिया हुआ है टेक्स्ट बुक में। आप ज़रूर थोड़ा एक्सरसाइज भी अटेम्प्ट कर लीजिए और इसके बाद हम एक दो और शायद आइडेंटिटीज़ ऐड करेंगे, लेकिन फ़िलहाल तो ये जो सेट है बहुत अच्छी सेट है। तो चलिए इसको जल्दी से एक बार देख लेते हैं। दी मोस्ट कॉमन आइडेंटिटीज़ एंड द मोस्ट बेसिक आइडेंटिटीज़ जो आपने सब ने बहुत यूज़ किया होगा. So these are the four where you have x plus y whole square is equal to x square plus y square plus 2xy plus y square. So there's nothing much to be told here. You just have to write this factor 2 times and multiply it out systematically and you will get this. And pretty much the same for x minus y whole square. You just multiply it out and you will get x square minus 2xy plus y square. And these are definitely very most commonly used. And this next one is the one that जो आप लोगों ने बहुत ज़्यादा यूज़ किया होगा. So either you can say that x minus y and x plus y are factors of this, or you can say that this is the expansion of this. So now there's nothing much here. Again, you take these two factors, multiply it out, and you will get this. But nevertheless, it is very important. And the last one you can see here, and if you look carefully, there is nothing much here. You just write these two factors and you expand it, and you will get x square, and you will get a plus b into x plus ab. Now the only interesting thing that we can say about this is that this is the explanation for your factorization of the quadratic by splitting the term. So when you use the splitting the middle term method, you must be wondering why it works, and this identity is all you need to know to see why it works. So with that, we have done with the four basic identities. Let's look at the next few identities, which are again fairly straightforward. So one second before I get to this. This one is also very simple. Oh, not this one, sorry. This one is also very simple, very simple, I would say, but also very useful. Again, there is nothing much here. You just have to take the LHS x plus y plus z and write it 2 times, and then you just multiply it out systematically. And when you multiply it out systematically, you will get a nice symmetric term like this: x square plus y square plus z square plus 2xy plus 2yz plus 2zx. And it is worth remembering this simple formula. So let's get to the next one. Our next one is definitely again very commonly used. Let's spend 2 minutes on this. So though there is nothing much to explain, this can be remembered in two ways. So we have x plus y whole cube. Now all you need to do is write it as x plus y whole square into x plus y and just multiply it out by brute force, and you will get x cube plus y cube plus 3xy into x plus y. This is one nice way of remembering this equation, but sometimes just the complete expansion into 4 terms also is something that people remember in this form. And again, sometimes it may be the thing that you're looking for, okay, and this is the way that you can remember it. Now in both these forms, look at this form and look at this form. In both these forms, if you just replace y with minus y, you get the other two identities. So basically here, if you replace y with minus y, you will get x minus y whole cube, and for the answer you just take this expansion and put y wherever there is minus y. So for example, x cube, there will be no change, but instead of y you put a minus y and cube it. In that case you will get minus y cube, okay, because it's a cube. And then again you have minus 3xy because you have replaced y with minus y, and again you will get x minus y. So this is the answer for x minus y whole cube, and once again you can write it in the form of 4 terms here, like this one. You will get 4 terms here, and here too you replace y with minus y, so you will get x cube minus 3x square y, because now there is minus y, and here it doesn't make any difference because we are squaring x minus y, so minus y into minus y is also y square. But here again you will get minus y cube, because here if you replace y with minus y, you will get minus y cube. So this is the explanation for this formula, and now we are just left with one final identity in this collection, and this one is hard to explain. Oh, not this one, sorry. This one is little hard to explain, but ठीक है, एक ही जो है जो हम ठीक से explain नहीं कर पा रहे हैं, लेकिन हम इसको वापस एक future में we'll come back to this identity, and there is a topic, very important topic called symmetric polynomials, and when we study symmetric polynomials we will be able to justify this particular factorization. So right now just note that x cube plus y cube plus z cube minus 3xyz is a nice and symmetric polynomial, and when it factorizes also you get some symmetric looking polynomials, and you will therefore not find it very hard to memorize this. X square plus y square plus z square minus xy minus yz minus xz, and this is the formula that you please memorize. Now I'll give you a very crude explanation for this, very crude explanation for the time being. You can consider this as a polynomial in x, and I'm going to find out p of minus y minus z, and basically I'm using the factorization theorem. Just to remind you of the factorization theorem, if p of a is equal to 0, x minus a is a factor. So that's what I would like to use here. If by chance p of minus y minus z equal to 0, then x plus y plus z is a factor. So basically the only reason why I'm doing this is because this might look like a nice use of the factor theorem, which is really our main lesson. So now once this is a factor, so at least I've convinced you that one of them is a factor of the LHS. Now what about the other factor? Well, you could simply do division, and that's how we began this whole set of lessons, saying that division of polynomials is very important. So you could divide the polynomials and get the answer, but as of now let's just stop this lesson by finding out this as a good simple example calculation. So what I'm going to do now is I'm going to just evaluate this. Okay, I'm just going to evaluate this by considering this as a polynomial in x. So here this is a polynomial in x, and I'm going to calculate this one, p of minus z minus y, and try to convince that this is 0. Okay, so here it is. I want to evaluate what is p of minus y minus z, which is in this polynomial, wherever there is x, you replace it with minus y minus z. Okay, and it's a polynomial in x. So now this will be minus y minus z whole cube plus y cube plus z cube minus 3. Now it's yz into x, but remember that for x we are writing minus y minus z. So this is minus y minus z. And now let's expand it and see what you get. And for this part we just have a formula. So let's use that formula now. Well, minus is there, and then you have y cube plus z cube plus 3y square z plus 3yz square. So I've used the formula for cubes, which we have just learned a few minutes back. And then what is left is, well, what is left is all of these remaining yet. So let me write it down. Plus y cube plus z cube, and then you have, I'm going to expand this, minus into minus plus, so plus 3y square z plus 3z square y. And there you see everything cancels out very nicely, and yeah, everything is cancelling out, and you get a nice 0, and therefore this is 0, and therefore by the factor theorem x plus y plus z is a factor. Now, like I said, this is really a bad explanation for why this factorization might be true, but we'll get a very nice explanation when we study a very important topic called symmetric polynomials, which is going to come very soon. But for now, please do solve the exercises that myself and Hilal sir have been constantly reminding you. You must solve all the examples in the book. You will be a master of these basic 8 identities, and trust me, they will always be useful for you. They'll be very good friends in all your algebra. So with that, I stop today's class, and I'm going to post today itself a series of geometry classes, and let's learn some beautiful geometry, but in a slow and systematic way. Remember what I told you when I met you. As you get to some serious geometry and some tough problems, please use your geometry box, because the real fun is in drawing some very nice pictures. With that, we'll stop now. All the best. Bye bye. Good night.